physics is simple. Now in this lesson, let us see how easy it is to derive the formula for capacitance of a cylindrical capacitor. So cylindrical capacitor will have two coaxial cylinders. Their axis is same. The inner cylinder, say, has a radius of small a, and the outer cylinder has a radius of small b. And this cylinder is quite big. The length of the cylinder is much larger than b. So L is much greater than b. So this we take like that because at the end of the cylinders there will be fringing of electric field. Fringing of electric field. That means the electric field will get distorted. Here the electric field may be like this, but here it will get distorted. So therefore, we don't want to consider the end effects. So the length of the cylinder is large. Now we want to find capacitance. To find capacitance, there are 4 simple steps. Only 4. First step is we'll put a charge plus Q on one plate and minus Q on the other plate. The capacitor can be of any shape. Even then we call those two as plates. Okay, so here also we can call them plates. The second step is to find the electric field. Once we have found the electric field, then we find the potential difference between the plates, and then we find capacitance as Q by V. As simple as that. So now the next job is to find electric field. Here electric field will vary with distance. This is not a uniform electric field. Okay, this diagram may make you feel that is a uniform electric field. Actually it is not a uniform electric field. So let us try to find the electric field at a distance r. Now how can we find that electric field? We have to apply Gauss Law. And for Gauss Law we have to use symmetry. So we'll draw a symmetrical Gaussian surface. A cylinder of radius r and that same length L. This cylinder has got radius r and it has got the same length. It is cylindrical, and this Gaussian surface has to be closed. So we'll assume that the cylinder is closed by end caps. So both sides of the cylinder are closed so that we get a closed surface. And then we have to use symmetry. It is very easy to understand that electric field will be radially outwards. So at every point on the Gaussian surface, electric field is radially outwards. And the area vector at every point on the Gaussian surface is also radially outwards. So E vector and dA vector are parallel everywhere. And because this is a symmetrical Gaussian surface, that curved surface, therefore magnitude of E vector will be same at every point on the Gaussian surface. There will be no electric flux through these flat surfaces. All the electric flux will be through the curved surface, and at every point on the curved surface E vector and dA vector are parallel, and E vector will have the same magnitude at every point on this Gaussian surface. So therefore the flux of the electric field, which is given by integration of E vector dot dA vector over the closed surface, will simply become E into A, where A is the area of the curved surface. the curved part of the Gaussian surface. And this by Gauss law is given by Q enclosed by epsilon naught. And therefore electric field becomes Q enclosed is Q. So Q by A into epsilon naught. A is the area of the surface area of the curved part of the Gaussian surface. And this will be circumference 2 pi r into the length L. So this becomes Q by 2 pi r into L into epsilon naught. This is the electric field. Now everything here is a constant except this r. So we get Q by 2 pi epsilon naught L into r. Now we have to find the potential difference between the plates. The potential difference between the plates will be given by integration of E dr from A to B. Right here, electric field is variable, so to do this integration. So we get this as, these are constant, Q by 2 pi epsilon naught L, integration of 1 by r dr from A to B. Integration of 1 by r dr is ln r. When you put the upper limit, we get ln b. When you put the lower limit, we get ln a. So this will be ln b minus ln a. That is ln b by a. So we get this as Q by 2 pi epsilon naught L ln b by a. So now we have found the potential difference between the two plates. And once we have found V, finding capacitance is very easy. C will become Q by V. So if you divide Q by V, this Q will cancel. This 2 pi epsilon naught L will go upstairs. So we get 2 pi epsilon naught L divided by ln b by a. This is the capacitance of a cylindrical capacitor, 2 pi epsilon naught L divided by ln b by a.